Welcome for our talk from Kent Archie. Kent likes to do these things, and he's doing his first online one. So congratulations, Kent,
Thank you.
for
Thank
Uniform
you.
Chicago having your first, or not online, your first Uniform Chicago online. I don't know if you've had other presentations done online someplace else, but we'll
Not
get
in
to that
about,
later.
not in like 25 years.
Yeah.
So
So as we like to do, this is our fourth fifth, because we had to March. So this is our fifth online general meeting. We had to skip May, I believe, uh, but we're getting better at doing these presentations online, and we've got more people to sign up for these compared to the pre-virus in-person general meetings. So if you would, let me start off with our part of our business thing is if you want to help support the Uniform Chicago group monetarily, you could uh, either uh, do 12 months of for $40 for being a paid member, uh, or another way to support the group would be to say, hey, I have a presentation I think Uniform should like to do, which, as a matter of fact, Kent is providing tonight. If you have a paid for membership, or if you're a speaker within the last 12 months, we usually have a pizza party in December instead of a general meeting. Whether or not we actually have an in-person general meeting pizza party in December this year, we don't know yet. Given the lack of the ability of everybody to stay healthy, we might not. But the idea would be to have, if you're a paid member, you would get your pizza and pop paid for at the meeting, at the pizza party, or you would pay some extra money instead of. Other things. Let me see. I know we have several of our board members here. Let me do a quick check. And by the way, we have 26 participants checked in so far. Okay, so we have myself as a board member, Scott Nemick. Wayne Schneidman is a board member. And I'm looking through the list. John Rapsey is a board member. John Spazeri is a board member. That's 4 of us so far. And I already talked about Wayne. So 4 out of the 7
Mike is a
board
member.
members that we currently have.
Mike is a board member.
Is there anybody else?
Mike.
I think I mentioned the 4 of us that I see.
Mike.
Oh, and Mike. And we have Mike Andrews. And we see him. Yay, Mike. Okay. So that's 5 of our 7 board members. We also have Ginger Wong and David Young as board members. So if you have anything you would like to provide to Uniform Chicago, either go to our uniforum.org regular website, and on the front is the front page is a link to information on our PO box, so you can mail a check for $40 or some other non-cash financial instrument to Uniform Chicago to that PO box. And yes, you can become a paid member of Uniform Chicago. Or, like Kent, you can be considered a paid board member by presenting us with a title, abstract, and bio for an idea on a presentation you would give in a future general meeting to info@uniformchicago.org. See, we currently are looking for those for the rest of the year. We might even have a December general meeting instead of the pizza party, just to keep ourselves busy into winter. All right. Anything else? See, I think Mike has everybody locked down except for me and muted. So let's see. Anything we want to in the chat we need to talk about? Okay. Have a question, Mike, when you have a chance. Having trouble locating the past two recordings? So that's something that can be talked about later. Also have an early question to Kent about the write-up on the on tonight's meeting, asking for whether or not you meant something to be true. So you can talk about that during your presentation, Kent. Oh, you already answered that. Okay, there we go. There we go. So Mike, so yeah, the URL with the V in it instead of the C is not a valid regular website. Okay, I think that covers everything we had in the chat so far. And I believe we went through all the group business stuff that we needed to talk about. If any of the other board members wanted to bring up something that they wanted to do to have mentioned that I didn't mention, add in the chat.
Does anybody have any jobs?
Ah, yes, things that especially nowadays we've asked in the past and we've started asking again is whether or not you are aware of any jobs that somebody with the illustrious list of people we have joining us tonight, whether you have any job openings that you might want to pass along to the rest of us. So sometime during the meeting, please add some of the information in chat, and we'll make sure that the information gets passed along. Anything else, John? That's good. That was a good thing I was asking about.
Anybody who's not speaking can mute.
Or you could put it in chat. Okay, so I'll tell you what, let's just get along to Kent so we could get Mike aware of how to do things with AWK. So Kent, take it away.
Okay, did the appropriate person push the record button, or am I supposed to?
There's a blinking red light in the upper left corner.
Ah, yes, I see it. Okay. Scott, if you notice anything in the chat, like a question that went past me, give a holler.
Will do.
Okay, so let's do this. All right. Okay, so my name is Kent Archie. My email address is there on the screen on the first slide here, and the location of the slides is on there as well. There should be not only the LibreOffice version of the slides, but a PDF of them on there if you want to get those. Okay, so AWK. The first question that I think needs to be answered is why? Why talk about AWK? Because we got Perl, we got Python, we got Shell, we got lots of things. Why another one? Well, I think AWK predates most of those, but that's not a reason to use something. And if you spend a lot of time programming in Python and Perl, continue to do so. My reasons for not using them are, idiosyncratic. I don't like Perl because I think it's too weird and complicated. I keep making the same errors every time I use it. And Python, I don't like white space as a syntax thing. It's just a personal annoyance. Otherwise, it's a fine language. You can do all this same stuff in it. But this has been around for a long time. It's there in Unix, in the command line. So you might not have heard of it. Maybe you have. And I'm going to tell you some more about it so you can decide whether it's of use to you. It started in 1977, like it says here, at Bell Labs by these three guys, Aho, Weinberger, and Kernighan, and their initials became the language name, because I guess they weren't very imaginative. The Aho and Kernighan, you know from these two books, or at least a lot of us do from the Dragon book there on compiler design, if you're of a certain age. And the C programming book, I think most people in our business has heard of. And they got together and they wrote this book, the AWK programming language that I came across sometime in the late 80s, the previous century, and was quite astonished by all the things it could do that I didn't know you could do. So I gave a talk to my work group at AT&T, the real AT&T, not the one that's pretending to be it now, and about all the things you could do with this, because I was so surprised at it. And a couple of the people had been assigned to develop a backup system for our servers, and they decided to write the whole thing in AWK instead of in C, I think just because it was something new to do and something different. So from that, you can get the idea that you can actually do an awful lot with this besides what it was originally intended for. It's kind of like having a C interpreter in your command line. Most versions of Linux come with probably all three of these. AWK is the original from the olden times. Nock is a rewrite from the mid 80s, and gawk is the GNU version, which added some stuff and is a rewrite. And I'm using gawk for all these just because. I mean, I'm not. Gawk has features, particularly in its array handling, that are superior to the original AWK. So, but otherwise, you know, it's AWK. Okay, so a lot of times, most people, AWK is used by people just as one-liners. And these are some examples. We're going to see some more later on. So this first one just prints a number in hex. Doesn't maybe come up all that often, but it just gives you an idea of how if you can be writing a shell program and want to format your output in some way that Echo doesn't support. So you can use printf like this to output values or you know, lines from your program. You can, we'll discuss in a moment the overall structure of it, why it's suited for some things. And this next example, in the middle here, is just prints a range of line numbers from 8 to 12 out of the file you give it, or the input you pipe into it. You can print out all get the usernames from password and sort them. These parts will make a little more sense very shortly, because we'll talk about how the AWK deals with these kinds of things. There are a number of lists. This is just one of them, of these kinds of little utilities. And like I said, there'll be some more of those later on. And there's a link later on to another place where a person went through one of these lists and explained how each one of them worked. So that you might find useful. An AWK program has a number of sections that are kind of all the same. They all have the same kind of pattern. Let me jump ahead one, because I think I want to, wrong way. they all have a pattern that looks like this. There's some kind of pattern matching expression, and then inside of braces, there's an action, one or more or hundreds of lines of code to do something. The pattern is applied to each one of the input lines. The basic purpose behind awk is to take a file of data that's line oriented, read it in line by line, apply the patterns. If they match, execute the code on the line, or do anything else you want because you saw that. So I think some of its original goals were to use it for like report processing. This is really good for reading and analyzing log files. So the aim of it is this kind of a structure: read a line-oriented file, recognize the lines you're interested in, and then do something with them. So back here is just sort of this doesn't do anything, but it kind of shows the basic parts. There are two of these kind of pattern action blocks that are special. This first one starts with a pattern called begin, and that's executed just once when the program starts, before it does anything else, before it pulls in the data, before it does any processing. And then end, which once it's finished the entire input, then it executes the end code. These are both optional. You don't have to have them if your code isn't doing anything. A lot of the one-liners don't have them. Some of the one-liners only have a begin. They don't have anything else. You can have whichever part of these you want. If your program, like the thing I was talking about with the backup system, all the code I think was mostly sitting in the begin block because there wasn't as much file processing in there as in other kinds of applications. So this is going to just print this line out at the beginning. This print before processing lines goes at the beginning. Then for each line, since there's no pattern over here on the left side, it's not it works on every line. This default is that it should work for every line, and it executes this code which just prints this built-in variable $0, and $0 is the input line, kind of like was a $_ on Perl. Maybe not, but and so all this does basically is it prints the lines of the file out with this begin and this after statement. Not a particularly useful thing, but this is kind of the common structure. The default action is to print the line if you don't have any action. So for example, this is the kind of the classic begin hello world program for awk. Is in the begin section, you just print hello world, and that's it. It's no other processing, no files are open, nothing's read. It just does that. This one, the second one here, this gawk with just a print in there, prints the file, which is, this is the equivalent of cat, but with more letters. Similarly, this gawk $0 also prints the file because all the lines match, and it just prints by default. So it's a very, you have to think about the problems a little bit differently, but the basic deal is this: you don't usually write ones like that. That's kind of a trick just to show weirdnesses in the language. But okay, so some of the default behavior is awk expects each line to be a separate record. It's, like I said, aimed at line-oriented files. You can in awk tell it what the record separator is. So usually it's a new line at the end of the line, or I guess character turn line feed if you're so inclined. But it's So it looks at every time it runs into a new line, it says that's the end of a line, treats that as a record and processes it. But some kinds of files have different kinds of structure, and you can tell awk what to use as a record separator and as a field separator, and they can be fairly complex. So you can you can read in different kinds of files. Like I said, mostly log files log files is a common use, but there are some kinds of log and config files where the records are separated by 2 blank lines, so that you can have blank lines in the record. Well, you can tell awk if you see 2 blank lines, that's the end of a record. You don't, and it'll automatically break it into pieces that way. And then once it's got the records, it breaks them into fields. And again, you can specify the field separator. By default, it assumes that the fields are separated by a space. But you just tell it it's a semicolon or a colon or a tab or anything else you want it to be. And it will break the line up or the record up into pieces based on that field separator. You can use regular expressions to make the field separator, so you can it can recognize multiple characters as field separators. It's pretty expressive. Once it's done that, it assigns a bunch of variables to the fields. So $1, $2, $3, they mean first field, second field, third field. $0 is the entire input line. Okay, so there's sort of global variables or system variables in awk to tell it some of these configuration details. FS is the separator for fields. OFS is how it separates fields when it does output. So you can actually, I don't think I gave an example of this, but you can read a file in one format and print it back out in a different one. You could read in a comma separated file and output all of it as semicolon separated, pretty much just by reading it in and printing it out. The RS is the record separator and ORS is the output record separator. So you can set all these things from the command line. You can set them inside the program, and then that will break up the records into pieces, which you can then process. Okay, so Etsy password, at least on my machine, looks like that. And if you tell it that the field separator, FS, is a colon, then it breaks it up into columns based on the colons here. So the variables have these values. The pattern part is, you'll see various kinds of examples throughout what we're doing here. So, but in particular, this one was one of the examples to print out line numbers and or print out our line range. NR is another one of the awk global variables, and it's the record number, the number of records read so far. So it's, you know, starting at 8, ending at 12. It will print those because the default action is to print. So this matches only the line numbers 8 through 12 inclusive. Right. Okay. So if you want to print those lines, that's how you do it. Okay. So this is a little bit more of an actual program. This is going to look through the password file and print out information about me. Look at for my login. And this is a regular expression match. So the begin part sets the field separator to colon, because in the password file, that's the separator, and then just prints this header. Then it looks at each line, and if this pattern matches, which is Kent at the beginning of the line, then it executes this code. So then which is just a printf, and it prints the 5th and 7th field. 1, 2, 3, 4. I don't think this is a whole line, but this is going to print out my information, my name stuff here, and which shell I'm using. And this is another way to do the same thing. Or I'm looking to see. This is, I don't know. It's a little bit different. This is looking to see. First, it's looking for people that have a non-bash shell. It searches each line looking for bash in it. If it doesn't find it, that's true or false. And then this reverses. This is a not. The bang here is a not. So if it doesn't have a bash in it, then it prints these 2 fields out. So if you wanted to look for people who are using something else as their shell,
With the
I'll let
slashes,
you
does that
figure
mean-
out why you want
is
to do
that
it.
a regex then?
Say again?
With the slashes there, does that mean that you could match on a regex?
The slashes here?
Yeah, usually like those slashes, in
Well, those mark off the regular expression.
yeah, so that's what I was asking. Okay.
You have another question, Kent, from Peter Fails.
Oh, he's not here. Never mind. Go ahead. I'm not. Do I have a?
Yeah, Peter, you can unmute yourself if you want to ask.
Yeah, I don't see the chat.
Oh, okay. I actually had 2 questions that came up. One is on the previous slide. I was just trying to remember. So when you talk about FS being the field separator defaulting to space, and I was wondering what would happen if you had like X space Y. Is that 2 fields or 3 fields?
That's an excellent question, and we can probably try that. I'm not sure I have something with that in it.
It's white space.
If you want it to okay, part of answer to that is if you meant for 2 spaces to be the separator, you can tell it the separator is 2 spaces.
I was thinking more of just a string of white space being a separator.
I don't know. I haven't.
Not something to get hung up on. I was just curious. The other,
Yeah, no, I appreciate that.
the other question is related to your current slide. It seems like that's not really the right test because, like, what if the person's username is bash?
Yes, I am not going to. There are a number of examples in here where there's various error situations I haven't addressed.
Okay, I just tested the FS default of space, and it's the default is white space, not the character space. So it treats multiple spaces as a single separator.
Okay, good. Thanks.
Okay, cool.
Yeah, and you're right. There's another example later on where you're just for purposes of example, you're looking through a file and when you find a line, you want the line before it. I'm not sure what that would have a practical example on, but it kind of shows off parts of the language. But that fails if the line you're looking for is the first line. And so then they had another version of it where they dealt with that situation. So a number of these examples are going to have holes in them because they wouldn't, if I put in a bunch of the error checking, it wouldn't fit on a slide. But feel free to, comment on stuff like that or find mistakes or things that aren't clear or inconsistencies. I prefer to have my code working than that it be the way I wrote it. So if it's not working, I want to hear about it. Or if there's a better way to do it, I want to hear about that too.
All right, thanks.
Okay, so there's a lot of what I'm going to do is examples of things in the language so that, you can just see the capabilities of it. I'm not trying to convince you that whatever you would normally use for these kinds of things isn't as good or that this is better than everything. This is just another thing. there's very little in what we're doing here that you couldn't do nearly as easily in Perl or Python if you're familiar with those. If you're not, I would argue this is a little easier, but I'm not going to argue that it's a better choice. Okay, so where did I go? There we are. Okay, this one is going to take an ls-l list and just print out stuff about it. So this is just showing a little useless program because it more or less is doing it's doing what ls-l does, except it only prints a few of the fields. Okay, so begin just sets up a title line for this, and then for each, there's no pattern for this action, so that means that it applies to every line. The field separator in ls is white space, like this, and so that's the default, so it doesn't need to just set up that. And then we're just going to print out these three fields, and then when it's all done, we print done. I mean, this is not doesn't come up all that often, but there is a thing to notice in here, in that there's this 0, which you didn't expect, except this is what you normally get from ls-l, is this first line is the total number of blocks used up in this bunch of files. But we don't want that, because we're looking for just the file size and owner. So we want to get rid of that. And we're going to find a couple problems with this. So the middle line where it's printing out information is supposed to have you can put a pattern in front of it. So what we can do is use the pattern to differentiate between the lines we want to process and the other stuff that we don't. So in this version, it's the same thing, except there's a pattern in front of it which looks for a leading dash, like all these have. And it only looks at the lines. Somebody keeps walking up and touching the keys here or something. So any line that starts with a dash, it's going to print the information out, but any other line, like that total line, is going to be skipped. So there, the 0's gone, the rest of it's on here, and success. Except one might wonder what would happen if you had links. Because in a link, the permissions thing here starts with an L. And if you run out a little program here now, you don't, this line, the link, it doesn't show up in the list. So we need a different way to solve that. Fortunately, we just have regular expression matching, so it's not a big deal. Here's a couple of examples of ways to do it. Is you can make an OR out of it. So if it starts with a dash or it starts with an L, deal with the line. Or you can do it the opposite way and just look for the total. And if you find that, if you don't find the total, then print the line. This is just sort of a demonstration of flexibility rather than, you know, that this is something you do every day. This is, at least in my quick hack, the more or less the same thing, except done in Bash. I have no doubt that in my Bash things here, I did not put a lot of time into trying to figure out, you know, the most efficient version. So actually, if you've got more efficient versions, or for instance, if you want to demonstrate how much better the Perl or Python version of these little scripts that I'm doing in here are, please send them to me, because I think it would, in the event I ever do a talk like this again, that would be a nice comparison of here's how you do it in Awk, here's how you do it in Python. You know, I just didn't take the time, and as mentioned earlier, I don't really like Perl and Python, so I skipped that part. But if you want to, you know, got nothing else to do, and want to write other language versions of these same little scripts, you know, feel free and send them to me, and I'll put them in here with your name on it, so people can see that. So anyways, this one takes ls minus l. It greps out. This is our first version. It greps out lines that have a dash in the beginning. Then it squishes all the white space. Uses cut to break it into columns, and then and doesn't do anything because with it. Oh, they show up in here. So you get this, and this doesn't look quite right, and that's because you don't get these in that order. You get them in numerical order, the output from this. So this comes out not the way you want. But you can fix that with something more complicated. At least I thought it was more complicated. And again, there may be other better ways to do this. Feel free, and I would be delighted to see better examples. But in here, we run the same kind of string through here, but then we run it through a read with variables on it, so we get the explicit values. And then we echo the ones we want in the order we want, and then we get the table the way I expect it. Variables and how they work. Variables are pretty much are just global across the entire thing. So, be careful. All right, so in this one, we're going to add up the sizes of all the files. Another not terribly useful thing. But the way we're going to do it is in the begin section, we initialize a variable to 0. We search for the lines. We're going to forget about the link problem this time. And it prints the data about things, and then it just sums into this variable total size. And when the whole thing is done, it prints total size, and there you go. On slides like this, unless I missed them somewhere, some of these longer bits of code, they're in files that are in with everything else. So you can, I did that because if I wanted to run this because we wanted to try something, I wouldn't have to copy and paste from here.
I noticed that you like to use printf. I assume you can use print and then this total size, just dollar total size. So print total size equals dollar total size.
No, it's the dollar ones only apply to the ones that are coming through the input process. Yeah, your variable is just total size, like most languages. These are special to the.
So if you want to print out your own declared variable, you have to use printf. You can't just.
No, no. I think you can just say print and total size, and it will come out.
Oh, okay.
It's just I like the control of the formatting. So I've kind of gotten in the habit of it. I'm also have a bad habit of forgetting which way I want to make these because printf either does or doesn't have parentheses around all this. And I guess I haven't decided which way I like it because I think I do it one way and sometimes the other. Okay, so this is, again, a quick hack at a shell version that will do it. Now, this was interesting to me, even though it's kind of, not really the topic, but this is interesting to me because the first pass I did on this, whenever it did this arithmetic on the value to update total size, it would disappear because the while loop is in a separate subshell from where this variable is. So at the end, total size was still 0. The one that was being updated was the one that was inside the subshell. So I had to, the way I fixed that the first pass was to dump this value, total size, into a file and then reread it every time around the loop, which is kind of ugly and clumsy. But then I found a thing where if you wrap the while loop in the pair of braces, then it's inside the same shell. And then total size gets used like you'd expect throughout the whole thing. So it's not making all these files or this file over and over again. I thought that was interesting, even if it's not really an awk thing. Okay, so here's an example of something you can do in awk, but it has not a lot of actual value. This is a web server, a very limited web server. In fact, as near as I can tell, this will serve exactly one file. But the point is that in gawk, you have access to networking code, so you can set up an HTTP service on port 8080 in this case, read data from it, and if it matches what you want, then there's somewhere in here where it tells what file. Oh, and then it sends out whatever this file is that you set this up with. There it is. So you give it a file on the command line, and that it's sent back. And that's all it does. If you want to do something else, well, add a whole bunch of other code to this. So I guess it's just a point of showing that you can, this can be a sort of general purpose programming language. I do not recommend developing an entire web application using this, but you could, I guess. Okay, so this is the most, to me, this is the most interesting part of awk is the use of associative arrays. You don't see, well, a lot of modern languages have the equivalent of this in the form of maps. Python's dict, C# and Java have maps of various sorts. Other languages have them too. It's a name and value pair, and the name and the value generally don't have to be any particular type. So it's not, arrays in awk aren't really in a proper sense arrays. They're not fixed length, and they aren't only one type. But that's okay because they're useful. But so you can have, as we can see here, you can have numeric indices in an array, but you can also have strings in the same array, and use them that way. You can look things up based on the strings. That is a pretty powerful thing for dealing with a lot of the data you read in. We're going to be playing with some comma-separated value files as part of the examples coming up. And you can, for example, read in the first line of those is typically the names of all the columns, and then you can use those names in the rest of your application by saving the values in an array with that name of the column. The standard awk doesn't have multi-dimensional arrays directly. The way you simulate them is you put the first dimension followed by a separator followed by the second dimension, and so the real index is a single dimensional array, but this is keyed as 1, 2, 1, 2. So you could also have a 1, 3 and a 1, 4. So it acts kind of like a two-dimensional array, but it isn't really. That's a little on the clumsy side, I think. But you can make it go, and you can make this as much as you want. 1, 2, 3, 1, 2, 5, 1, 2, 10, 1, 2 Bob. I expect you could do anything you wanted with it. But you've got to then, I mean, there's support. There's some support to make it easier to deal with looking things up when you have the two parts and that kind of thing. But a better solution is just to use gawk. Gawk has actual multi-dimensional arrays, and then you don't have to do some tricks around it. Some more things on the arrays. If you create a 5-element array in a C or something, but you put a number in only one of the slots, the length of that array is however big you made it. It's not just the one value you put something in. But with the associative arrays, an array here where in the 5th position or the key of 5, I put a 7, this array has one element in it. The length of this is 1, not 5 or 6 or 4 or any, anything else. It's just 5 is 1 because there's only one thing in it. So you got to be a little, you can get a little confused by thinking if I made this one, then the other 4 must be in there too, but they're not. You can loop over this just by using a for loop, and for loops look like you've seen a bunch of modern languages that index an array, and then you can print the value or the index and do whatever else you want to do with it at a time. But this will print, for this array here that we made up, this will print out exactly one thing. It doesn't print all the blank ones because they're not there. So that's one of the reasons why, technically they're not arrays, but that doesn't matter to anybody, not even me. But that's it's a different thing. So sometimes your mindset's got to be careful that you're going to treat these as if they were an array like in other languages you're used to, but they're not. They're a much more similar, to hash tables that you would see, or maps, or dicts, like I said before. There's some variations there, but they're much closer to that than they are to a regular array. One of the things, this is a sort of an anecdote about all this stuff. The first place I came across these kinds of data structures was in a truly horrible programming language that I made my early living at called mumps. It's had one data structure and they were B trees. And the way the syntax they used was a multi-dimensional array, where each dimension on the array was a level down in the tree. So kind of imagine if you had an array and tilted it on its corner, you kind of get a tree looking thing out of it. Not a real good one, but sort of. So as you look at, you can view the data as if it was in a tree, even though you're using the syntax of putting it in an array. And that's one of the interesting abilities. That's one of the only pluses for this language called mumps, is it had that. Everything else about it was awful. A actual line of mumps code would be WWII. And that would mean while W is true, no, that's not what that means. I've forgotten already what it means. The I is in, one of the I's is an if, and the other one is a variable. And it's just, if somebody offers you a job, double the salary or triple it if they want you to program in mumps. Okay, anecdotes aside, this is another little more stuff about the associative arrays. Is since it's sort of a key value thing, you're not going to, you may or may not see them in the order you put them in here. They're just arbitrary. So when you do this for I and R to print this array that you made up, they come out like this. And that's just because that's how the hash map worked, and that's the way they came out, even though you put them in, in a different order.
So it's not a sortable array.
You don't have control over that. I have some kind of guess that it's sort of sorting them because it came out 1, 5, 6, but then the 6 came out in front, so it's not the obvious way. Yeah, I don't believe you have a way of telling the arrays have any control over what it does with them. Some examples of the arrays, we're building up to arrays of arrays. This isn't all that great of an example. Well, it kind of is. Okay, so this is a bit more like C in the sense that C doesn't support two-dimensional arrays. It supports an array of arrays. It's a little bit different. It's a little bit fussy how it's different, but this is kind of the same thing here. So we have this array that we're putting in 2 values in the first row and the two columns, if you think of it as a two-dimensional array. But really what this is built as is A sub 1 is a array of two elements. So you can kind of nest them as you will. In this case, there's there's 1, and then element 3 of the array associated with 1 has in it an array that has a key of 1 and a value of name, and we're storing Barney at this place. You can get carried away with this, which I did, but don't think I'm going to show you all of that, because as I said, got carried away with what I was doing with it, and I'm not sure it was leading me to a useful example, but it was kind of entertaining. I was pursuing that idea of looking at it like a tree in a way that would be helpful, and I don't think it turned out to be. But we'll see how much time we have. Maybe I'll show you part of that. Okay, so this is pulling in a file full of data that you want to plot or are intending to plot or something. So it's just a column data that has two columns, two numbers. So the separator is a comma right there, and we're having a counter so we know where to put things. So the row is going to increase as we read each line, and on each row is going to have two elements in the array. So this is a two-dimensional array, and it's got this many rows, and each row has got columns, and there's the two values. 4.2 and 215 would be what are in these two. And then at the end of it, we're just going to print it out. So this is kind of useless, but it's just showing you how the structure works. So just like you might expect, you just nest the loops, and then print the two value. Put the address it the way you'd expect, I guess, or at least the way I'd expect, and then it prints the value out. So you get that. Okay, shouldn't have done that. Note to self: don't touch your mouse. Okay, so if you ever want to print out some data, you can do that. Anyways, the idea is that you can just use a two-dimensional array, kind of like you think you'd use it, right? You got the two sets of brackets, put a value in each one, get your data. The thing I have as sort of my extra time stuff has to do with some of those array values, or the indices, instead of being numbers, like in this case, are names of something. So you can have an array of names, and then for each array or element in that array with the index is a name of somebody, the second one could be an array of their children's names or something. You can nest up some pretty complicated things in here. Okay, so you can get carried away and get really complicated in it. This is kind of like how you would do that same thing in C. I'm not sure I have the whole program in here. I was just trying to show some of the similarities. In C, you create an array by specifying its size. I'd skip the whole malloc thing. I think that was introducing, or new or something. That was just introducing complexity I didn't need for what I wanted to do here. So you just create an array with the two dimensions that you want. Read in the string, split it up, take the value, stick them in the array, the same way we did with the awk code, and then in a very similar way print them out. It's almost identical. So it's just to compare it to something you're possibly used to.
Hey, Kent?
Yes.
Okay, there's something that was previously put in when we were talking about sorting, that gawk has asort and asort I functions.
But there's sorting.
Neil brought that up.
I'm not sure I understood the question.
No, basically we were talking about whether you could sort arrays.
Yeah.
And apparently gawk or gawk, if say it that way, apparently has a sort and a sort I functions that you can build.
Oh, to take one of these array structures and sort it?
Yeah, or something like that. I don't know
Oh, okay.
specifically, but I confirmed that the gawk has some sort of functionality using functions of that name to do something with it.
Okay.
So I just wanted to pass it along from things that people have been putting in. Yeah, there's been quite a separate chat going on in the chat for the different things you're talking about.
Oh, good. I'll read that when we get.
We can open it up to everybody when Kent's done.
Yeah, but I just wanted to pass it along in the middle in case there was something that somebody wanted to also talk about. But okay, thanks.
Yeah, there's a lot of stuff that I'm glossing over or not going to do. The gawk book, which is available free, is like 500 pages. So there's a lot more to this than it's interesting because I think there's a lot more to this than would probably be necessary to do the job it was intended to do. There are times when I read this and I think those three guys got carried away and just threw everything in there. So there'll be stuff that it can do that we're just going to pass by. So I appreciate that. Thanks. You can do functions. They look pretty much just like C and work pretty much just like you'd expect functions to work. So here is another terrific example. This is a function that takes a file, splits it, the name of a file, splits it on the period, assuming there is one. In Unix, sometimes there isn't. So there's lots of ways this can go wrong. But in any case, it splits it on that, and then it returns the last element. The splitting operation creates an array of the parts of the thing. So file name would have, if it has an extension at all, will have two parts. It'd be an array with two elements: the part before the period and the part after the period. And we want the last thing, so it returns the number of elements that it generated, and then the last one is going to be the extension on the file. So this function takes a file name, returns the extension. And then we just have, somebody come and take my mouse away from me. Oops, now I went too far. So chat amongst yourselves. Okay, here we are again. So this is a thing we had that reads the files, that takes the ls minus l thing before, and it takes each file and calls the function, returns that value, and then it's counting them. So I'm using this array types, and its index is whatever type the file had, .c, .awk, .sh, whatever it is, and it uses that extension as the key, and then it just adds a number to it at the value. So every time you see another file like that going through this process, it increases it. So at the end, I'll know how many sh files, how many awk files, how many c files I had in my directory. And in the end, we just print it out. So it's just a for loop because it's an array over this array types. T would have the key, and you print the key in the type. And if I did this way, I think I did, you get something like that. So what this is showing is just a couple things, which is what a function looks like, but also that you can use the arrays with values and do arithmetic on them. When you arrays are kind of weird in a number of ways, but one of them is that the first time you come into this, that element doesn't exist, and it creates this types of type creates an element in the array which is nothing, which is treated as 0. So then when it does the plus equals 1, you get 1. So you don't have to go through and initialize it unless you want to for some reason, but you don't have to initialize the values for all the possible types. This just keeps expanding. You never have to change this program because all of a sudden you've got .wav files and you weren't expecting those or something. Okay, so this is the similar problem in that we've got getting the file extension on there in here. I think nope, I changed the name there. Okay, so I have the same name for the same function. We haven't seen this yet, but you can make libraries of functions and include them in yours, so you don't have to make one giant file. We'll see that in a little while. So what this is demonstrating is that instead of piping the ls through the awk program, we'll just run it inside the awk program and use the results. So there's just a begin. We're not going to process the line by line from the outside world coming in through a pipe or a redirect. We're going to execute the command ls-l doing this egrep stuff that we had a while back, and then it's going to execute the command and do a get line and put that whatever it gets into this variable result. So this is sort of the idiom for that. While this is the case, then do something. So we've moved the line by line processing inside our program instead of being outside. Depending on what you're doing, that it may be entirely useful. So in this case, we take each of the lines coming in from this ls command here, split it into parts on space, because this tr minus s is a squeeze operation. It replaces, I think I'm missing something there. It replaces multiple characters with a single character. So if you got 3 spaces, it turns it into 1. And that will make this sort of parsable on space. So we split it in here, and then we get the extension from the last element in this array, which is the file name right there, and then add up the count and go on. So this is doing the same thing, but it's taking a different approach. And then we print out our collections, and we get the same thing we did a couple of slides ago. Okay, so this is I picked a couple of examples of short little awk programs because it may be rare that you're going to have to do some kind of big report on your web server log files, and you want to use one or more awk programs to process them and get a kind of a big thing. Sometimes you just want to do little things. And I think awk can do some of these things more easily than combining a collection of Unix commands together. Not always, but once you know what it can do, some of these things become clearer. All right, so off we go. Want to double space your file? Here you go, obviously. What else could you do? This is just true, so it prints the default is to print the whole line, so it does, and now it's printing an empty line too, so you get it double spaced. Some of these are not entirely obvious, but they're kind of clever. You can, when I was writing code, as you can see from some of these codes, I put line numbers on them because I guess that's kind of traditional. Also, if I wanted to mention something specifically, I could have used the line numbers. But I used cat -n for that, and it worked fine. But then I found this, which does the same kind of thing, but because there's a printf in here, which this time I put the parentheses around, you can, customize it. So it's always a total of 5, counting the digits, it's always going to be 5 spaces and digits. And then there's a colon, and then there's the line. $0 is the whole line. So this prepends the line with this right here. So you can do, put labels, do whatever you wanted to do to it. It's just, you can, most of the time, all you want is line numbers, and the cat -n thing works just dandy. Sometimes you might want something specific for the way you're doing your job, and then you get a line that looks like this. If you want to find out how many of your lines, how many if statements you have in your code, this will find lines that have if in them. This is not ideal because you're going to find anything that has an I and an F in it. But you get the idea anyways. And it increments a value n every time it finds an if. And then at the end, it just prints that value. The +0 thing, I think, is a turn a string into a number thing, which I'm not sure you really need, but that's what they did. So this goes through this file and counts all the if statements, or at least all the lines that have an IF in them. And you could make this pattern cleverer with your regular expression skills to make it more specific to the particular thing you're doing. But always remember the old idiom that if you have a problem you think will be solved by using regular expressions, now you have 2 problems. I like regular expressions, but be careful. A few more, just because I like them. You want to get rid of some of the white space. This is going to trim, I believe, the left. Does this remove all the white space? I think this removes all the white space. Yeah, so a regular expression to match the leading and trailing white space, and then it prints the line. So you can squish, get rid of stuff on the beginning and front of your lines if you want. This one is, it's an interesting thing, but I had a hard time thinking of something to use for an example. This will search for a file or a line that has whatever is in here, this regular expression, whatever matches here, and then only on those lines will it replace foo with bar. So that's what you can do. If you can come up with a legit reason why you might want to do that, that'd be helpful. That'd be nice. But it was just showing the flexibility of this. This is the global substitution on the line, on the whole line, the input line. So all the foos get changed to bars, and then this prints the line after that. Notice that this isn't an end thing. This is an additional action. So only it's kind of hard to see this because it's all written in one line, but this is the pattern part, and so if lines match it, this action, the G sub here, gets executed, but this also gets executed. This other action, it doesn't have a pattern in front of it, so it applies to all lines and it prints it. When you've made these changes, this is going to print the changed line because this is changing $0, the original input line, and this is going to print $0. So once you've changed it in the first action, this second action prints it. So it doesn't, from the top down, as it were. In other examples, we've seen that, and you'll see some more here. You can have multiple, as many as you want, pattern action things. It's a little bit like a case statement in a way, except there isn't any catch-all at the end. But so it does both of these things, and then you get all the lines printed with the substitution done in it. This is a cleverer thing, and it's a little hard to follow, but away you go. And I didn't put a file name on here, but there would normally be a file name that you wanted to process. This removes duplicate lines that aren't together. There was another version of this that printed if you had duplicate lines one after the other, which, if you're analyzing log data, that probably means some kind of mistake where it got repeated, not, that it's anything else. You might want to remove duplicates before you did other processing. But this one will remove lines that are separated in space. If line 1 and line 8 are the same, this is going to get rid of one of them, or you only end up with one of them. The way it works depends a lot on the defaults. You notice that there's no pattern, there's no action, there's just nothing but this little weird thing. So what it's doing is it's sticking, there's an array A, and it puts the whole line as a key value in it. If that line comes around again, this is already in this array. So the first time, it just sticks it in there and sets it to 1, and that's, or I think at least it's, yeah, and then goes on. Then it runs into the line again, and this time it finds it in there, so it increments it, which if you do a not, it becomes not 0, which is true. So it so it prints it. I figured this out earlier, and now I've lost it. So the reason this is in this list, I think, is that it's just a weird abuse of the defaults and how the system works. This is why I always wrote terrible Perl code. The reason it was terrible is because I couldn't keep track of all the weird little assumptions and default values and things in it. So I had to do everything explicitly, one line after another. So my code was long and ugly, but you could read it again a week later and know what it did, or at least I could. If I tried to write it in proper Perl, I wouldn't have been able to read it, but it would have been 3 lines and it would have been astonishing. This is kind of like that. If I was actually going to do this, I'd use sort of the same technique, but I would spread it out. It's just to make it more sensible. So here we want to print the line before the matching line. So you found a line, but you're interested in the line before it. I think I mentioned this when we were starting, is one of the things that you could do. So here's your regular expression. I guess in this case, we're looking for the word regex, but you put any regular expression in here. And if it matches, then we print what's in X. And then we set X to the current line. So every time you run this, X is the line before this line, this is executed on. So you print X, and that's the line before. The problem is if it's the first line that matches the regular expression, X isn't set and it doesn't work. So they gave another version, and the other version has the same kind of matching thing. But if X is empty, which is their version of null in this, then you got a conditional expression. Yes, we have those too. And if X is empty, which it would be on the very first line, then it prints out match on first line instead of anything else. Otherwise, it does what we did here. So if you're, it takes care of that error case. All right, this is a more complicated one, yay, or a bigger thing. What this is playing with is some data I had collected on grocery receipts. I had a I lost interest way too early. But I had ended up with some data where I had, the name of the store, what we bought, how much it cost, and when we bought it, and like what kind of a thing was it. We were the idea was to collect information and do something like, well, wow, look how much we're spending on ice cream or something. So I collected some of the data. So that's the data set that's in this, is that kind of information. So let's see what this does. First, this is how you do libraries, includes. You just include a file. And there's nothing special about this file. It just has awk code in it. There's no format, or it doesn't have a name of a class or anything like that. As far as I know, nobody's attempted to make object-oriented awk, which I view as a good thing. Okay, so this data is stored as a CSV, comma separated values. So we set the field separator to comma, and off we go. If this is the first line, we skip it, call next. This is on line 9. I should actually use the line numbers I put so much time into getting. This is a global variable, or an awk variable, and it has the number of records. So if it's 1, this is the first line. The first line in a CSV file is usually the names of the columns. I don't want to add up those, so I skip it, and next goes to the next line. There's also a break and a continue that have the usual meanings, but next is what we want here. But that means I also have to tell it to not do this other processing, or to do this other processing only on lines that aren't that, which it should never get to, but it works better this way. So I added, this is just for amusement value. This just gives me a little, every once in a while, telling me how much it's doing, so I know it hasn't hung or some such. So it's just a mod, if it's every 100 lines, print this out. So CSV parts, that is not an awk thing. It's a function that somebody wrote that parses CSV lines. That's what's in this line 2 here, this library. Somebody else wrote it. I took it, and this person wrote it. I did give credit. So you give it the line, $0 is the line you read in, and it puts the into the CSV this array. It puts each column as one of the fields from the line. So the first field, it goes into CSV sub 1 and so on. These are parameters that you can do because sometimes people write a CSV file, but it actually has a semicolon separator in it. If you've read CSV files into things like Access or some such, or spreadsheets, they'll often ask you, what's the separator character? What's this, are the strings quoted and that kind of thing. So that's what these parameters are about, is to tell this little parsing routine, look for quotes, look for commas, and like that. Okay, so and this is an error check, if the number of fields is less than 0, that means that this failed for some reason. And then you can print that out and then continue. Continue skips on to the next line. There's not like a while loop or anything in here, but it continues the processing. All right, so if it passed, I got it, I broke it up, then I want to I'm looking to sum all the prices. I'm going to end up with a bunch of totals that for each store, how much did I spend there? And the first entry in the CSV is the name of the store. The fourth entry is the price of whatever this thing was. For this purposes, I don't care. I'm not trying to divide it up in like, how much did I spend on ice cream at Walmart? I could do that with this, but I'm not. I'm just trying to stay what passes for simple. Okay, so that happens on every line. This array totals gets built up with the values that we're interested in. Then at the end, I call this routine walk array. This is again not a built-in awk thing, but it's a handy thing that somebody wrote, and I don't know if I remember who that was. But what this is where this idea of viewing the associative arrays as a tree, it gets to be kind of useful, because this walk array essentially does a depth first pass over the totals, the array that you give it. So it's kind of like a tree walk, but it's written recursively, so you can do that in it. Some scripting languages don't allow recursion, but awk does. And so it's a recursive depth first walk over the array. That's why I said somehow.
Kent, one question. How you're referencing that function without, is that's in a library somewhere? How are you incorporating
Oh, sorry. Yes, it is. It's in fact, this library, utilities. That's it's that. If you can see that. Does that answer or help?
Yeah, thanks. That's what I was just wondering.
Yeah, there's I'm not even sure that this shebang thing up here is necessary, because it's just going to pull this in and then make it part of your program. But you just put a bunch of code in there and then yank it in. It's kind of the @ include in here is closer to being like the C version, where it sort of physically copies all that text and slams it into your code before it hands it to the compiler. And I think this works the same way. But here's this routine walk array, and it looks at each element in the array. If it's an array, then it calls itself to print that. And so off it goes walking down the tree. Okay. So that's where that is. And then this parsing thing is in that file. Okay, so the walk just prints out everything in the array, and it's less typing than putting my own loops or stuff in there, so that's all this is about. Okay, so if you did all that, and if we did it right, then we don't end up with anything because I didn't put that part in here. But I end up with a file that has the name of a store, a comma, and the total amount of money that I spent there. So that's my plotting data, just because I thought it would be fun. And so this is done, and I could do something to plot with that. I could take that file, and I could, since it's a CSV file, or rather save the output from this as a CSV file, I could include that into a spreadsheet and then use the plotting programs in the spreadsheet to do stuff with it. But this is all kind of command line oriented, so I wanted to stay with that. So I found something I haven't used for a long time, which is where to go, GNU plot. And it's an extremely sophisticated plotting program that works off of a text file of commands, and it will plot something. In this case, I'm making a really simple one, but we'll see that in a minute, but it just seemed in the spirit of the thing to go that way rather than just dump the file out and stick it in some spreadsheet. So I had to add some stuff to the end of the previous program. This printed that stuff out, and here I'm getting rid of the file that I'm going to store the data in. And then here I print the data into the file. Each of the elements from totals, I print into this file, shop plot dat at line 32. And it prints quotes around a string. That's the name of the store. and then, oh, well, I guess it's a space separator rather than comma, but it puts a space and then it prints the value, the numeric value, and then a new line. So this dumps that out to the file plot.dat. Then using the system command, this is another version of how to execute things outside of awk. We saw that command line thing earlier, which would run the command and then you read the results of that. Here, I'm not interested in whatever GNU plot outputs to stand it out. I want it to do something. So I can just call the system command here at 35 and run this, which this file, testplot.txt, contains the plotting instructions, which I think we will see next. And yes, that's next. So this is how you use this GNU plot, is you just tell it things and then you tell it to plot. You can do very complicated plotting out of this. You can have multiple data sources and multiple lines drawn on it, different kinds of plots. I'm doing a histogram. It's a pretty powerful plotting mechanism for generating, and in this case, I'm generating a PNG file for the output. You can generate lots of other things too. It's really quite impressive. If you're like collecting, you have a bunch of logs or status files around, you want to collect a bunch of information and you have some graphs of the data chunk in it, you can use a combination of like some of these programs, GNU plot with awk or even with Python or Perl, and just run a program essentially that does everything instead of having to take the convert files to CSV, include them into the spreadsheet, and then go to the spreadsheet and say, okay, make a plot out of this, and then you can just run this all from the command line, which is kind of what I like. So most of this, I mean, it doesn't matter to us. Labels on the X and Y axis, a title for the whole thing. The style, this is how it draws the bars. And then this plot command takes the file of data that we generated back here, and it uses column 2 as the y-axis, and the ticks, the labels for the tick marks are from column 1. Column 1 was the name of the store, so this will use the store names as the x-axis tick labels, and the y value is the second column. And the boxes just tell it that it's like the standard kind of, bar chart kind of thing. And I made it all green. There's just endless numbers of things you can specify in here, but I think I had spent enough time on it. And then you get that. Apparently I shopped at Walmart a lot during whatever the time period it was for this, but this is not an advertising for any of these people. So that's just a thing. I combined the flexibility of awk and processing the data and collecting the results and then converting it from one form into another. So the raw data is not being plotted here. I'm doing some processing that first takes all the prices and adds them all together and groups them by store. And then that is what gets handed to the plotting routine. It wouldn't be hard to set this up to work in a spreadsheet. So as I added new values, bought more stuff and stuck it in the spreadsheet, it automatically recalculated a bunch of this stuff. And that might be actually a more useful solution depending on what you're trying to do. I'm more trying to demonstrate that this language has a lot of flexibility and power in it, and you can start to think of things you might want to do from it. That like the back in the previous century when I gave an entirely different talk, when I was first thinking about this, I went, this is great, I already have this talk. And apparently I threw that away at some point in the past. But anyways, that inspired these people to write this entire complicated multi-level backup system, including tapes and external disk drives, big ones, man, like 100 meg disk drives. This, I'm hoping that this gives you some ideas for things you might do. Not quite finished, although it looks like, it sounds like I am. So let me show you some of the stuff. Some references to awk material. I don't know, this is a bad color for these links. I guess that's because they're links. This is the big book on it. So that's just a PDF file. So if you want to get really carried away, you can go off and read that. Some pretty good tutorials. I was in earlier versions of this, I was fiddling around with a bunch of, I need a pile of data, something I could fiddle around with in this. And I found a whole bunch of old weather data. Like I was looking at temperatures in Scotland during the year I was born. It was weird. Okay, so I found some other stuff along the way. I found this language called Q. And what it lets you do is run SQL queries. It's pretty much just what it says. You can run SQL queries against a CSV file. I'm not sure I'll hear you, but anybody use the Unity back in the long ago days? It's a file-based relational database system in Unix. We use it at AT&T pretty often because I guess we wrote it and it was free. Well, this is a little bit like that. Your file is of your CSV file. In this case, my store prices or purchases is a table. And then you can write queries like this against that table and get your results, just like you were using a real database. If you were going to do a lot of stuff with this, I wouldn't do this. I would just stick it into your favorite relational database system, MySQL or Mariah, which are almost the same thing, or Postgres or whatever you're using, and stick it in there because it gives you more power and control. And I was talking to some people about this today. I don't know whether you can run like inserts and updates on this. I didn't pursue it that far. I just thought it was kind of neat that it existed. So if you want to play with it, there you go. Just because that's what this talk is. Okay, I wrote an awk version of more or less this same query down at the bottom down there where I can't have trouble seeing it. But we just look for everything that has milk in it because I'm searching for items where an item has the word milk in it. So I search for anything that has a milk in it, and then I just print those values, and so the same thing comes out. This is even less connected, but it's still in the same area of manipulating data. If you have JSON data, and that's becoming more common these days because it's kind of self-describing as opposed to, well, I guess CSV is sort of too, but JSON is more commonly used if you're building web applications and moving data around. So this is a tool for processing JSON data. Its simplest thing is this bit right here. You just, JQ is the name of it. That's where you can find out all about it, and it has a lot of stuff in it. I believe you can actually stick your own little bits of Perl code in here to process the data. So just putting a dot there just prints, it's the equivalent of an empty thing in the awk. It just prints the output, but in a more pre-printed kind of way. So this is just one of the records, but it just prints it. So that's not particularly useful by itself, but now you can start doing more interesting things. This little weird expression goes through each of the elements in the array. That's what these are, just empty square brackets, and retrieves the price field out of each one of them and then prints it out. So you can do a great deal more. I think I might have, yeah, one more here. Well, actually two more, but this prints the entire set out, or goes over the entire set and just prints the store and item fields. So I can kind of rename by putting values in here. I could rename the fields if I wanted to. And then it is also, projects out things that are on there. But this is not a proper JSON array because there's no comma in here and there's no open and closing square brackets. But you can fix that by just wrapping all of this in a pair of square brackets, obviously. The syntax is pretty confusing. You just have to keep playing with it. Fortunately, the website where you get this thing from also has lots of examples of things you can do. So you can start looking at things that are close to what you want, and then you can tweak them into what you want. So if you have JSON data, this is a really nice way to fiddle with it and alter it as you go along. Okay, I'm gonna hang on to you guys for a few more minutes because I just wanted to skim over something else. I'm not gonna, this is a more complicated application, is manipulating the data in different ways. The purpose of this was to show off things you could do with the arrays. So I'm not going to do a lot of that, but I want to give you a taste of it. So this is what the shopping data looks like as the CSV. So I'm going to do like a bunch, do several different things with it in here. Here's these incorrect utilities thing. I moved the code around, so these are wrong. I have to fix that. This is stuff we've seen before. I break the lines up, and here I just print out the values, and that's all this does. It just prints them out. But so that's not terribly interesting. So I just see the data. In this version, I'm collecting the totals of everything in an array here. We saw this before, and it prints the results. So I get, those are the totals. Now, each of these, the first line, now I want to, remember I mentioned how you could use, the CSV file has first line has the column headers, and since you could have arrays with names in it, you could use the names of the columns in your arrays in here to refer to things instead of having to use the column numbers. So this is the line that breaks up the titles. It's the first, if you're looking at the first line, then break that up into titles and then check for an error. And that's all that does. Okay, so after that, for the other lines, we do the same kind of parsing we've been doing. And then for this, for each one of the titles, I have my data array now, and it uses the title name, store, price, item, whatever it is, as an index, and then it stores the value for the corresponding field in there. So now here I'm printing all the lines out, but I'm using data sub store, data sub date, data sub item, which might be a little easier to read or do things with in there. And you get the same thing as we've seen before, just more complicated ways of doing things. And similarly, if I wanted to sum all the prices like I did before, I could say it more specifically. Totals with the name of the store gets set to price. I think it's just a little easier to read is the only real advantage to that. And this is an array of arrays that we haven't really talked about. In here, this is the thing I wanted to come here to kind of show you. The idea here is I read the entire file in, and I store each row is stored in a data object and as an array. So I'm storing an array of the values from the line as each entry in an array of all the data. That didn't really sound like it made sense to me. So maybe it'd make more sense when you see it. So this is the title parsing that I did on the last thing. Let's just kind of, and then here's the actual data lines being parsed. So here I have a counter so I can just keep incrementing. And that starts at 0 or 1. awk arrays don't have a natural or a starting point anywhere in particular. So I prefer to start at 0, but I think it was sort of in my head confusing could get confused with $0. So I elected to go start from 1, but that's a choice that we all have to make. So anyways, this data element is an array, and the element, the index for the array is just this counter. So 1, 2, 3, 4, 5, 1 for each line. And then that contains an array of the title elements, and then you set the value in it. So think of the file, what that originally looked like. You had each line, and you have these prices, names, stores, and all that stuff in it. Well, each row in this data array here at line 32 is one line from the file. And then in that element, so data sub 1 is the first row, or the first data row. And then that's an array that is of name equals value. So store equals Walmart. So I essentially now have in data all the data that was in the file saved in an array that I can now walk over, do calculations on whenever I want in memory, as opposed to going back and forth with the file. So what happens in this bit here, which is really hard to read because of the way it does, I'm printing the values out that actually I have these commented out, so they're just for my testing purposes. So we'll skip it because it's too hard to see anyways. And then I bump this counter every time. I suppose I could have stuck that in there so that I get this whole thing. So I don't know if that is making a lot of sense, but there's a lot of flexibility in how these things are used. So then when it's all over, if I do this walk array, it just dumps the entire data file back out, row by row. And here, so now I'm doing a different thing. I'm looking at each one of the entries, each row in data, and then I'm using that row, the store value from that row, and then this and adding the price up. This is that same expression we saw to calculate the totals, but it's going row by row through the data using the names of the columns. And at the end, we get the same value. I had written, and I'm not going to go through this one, I'll just skip it, but I had written an example, a longer program that took a CSV file and output the JSON version of it. It was, simplistic. It just made a lot of assumptions about the correctness of the data that wouldn't be realistic if you were going to do this for real. But I thought it was a big enough piece of code to be, that we could look at and would demonstrate stuff. This is just that, and some functions to trim off space, and then I told it that the data was all a bunch of strings, and then these are printf, what you want to call them, formats. So it won't quote the numbers and things like that. I'm not gonna. That's that, and it mostly worked. Okay, so now we're back at this. So if you have questions, and I think there were some along the way, but I didn't see them.
Like I was saying, Kent, some of the stuff in the chat was basically just kind of adding things to what you were saying as you went along. So I don't think there was anything in particular that they were saying. Stop! Ask Kent this.
Yeah, speak up.
I'm looking for there it is. Yeah, okay, so there you go. So immediately stop using whatever you were using and start using this obviously superior thing. I'm kidding. It's I like it, but it's been a long time since the last time I actually used it.
Okay, we can open up the floor to other business if you want to, I guess, Scott. Whatever. Let me just tell you personally, I put out the call last meeting for help with with my text processing problem, and Neil stepped up and set me up with an awk script that does more than I could possibly imagine. And now I'm the awk expert, and it's all due to Neil. So thanks.
Yeah. Neil was. If you, we'll try and get a copy of the chat session and save that off. Provide that along with the, because you're going to provide us with a PDF version of the slides, or?
Oh yeah, they should be. Oh, wrong one.
Yeah, probably if you want to give both, you can give your original one and the extras one.
Yeah, they are. They're already there. This GitHub reference down here is where they all are. And
okay.
it's a public thing.
Well, let's see. Could you put those in the chat?
Yeah, I was just thinking that. Let's see if I can do it. No, I don't really like LibreOffice. It's hard to grab text out of these things. Okay, let's try something different.
All right, Jonathan said, aren't most GNU utilities in macOS by default? No, I had to install gawk, which wasn't too hard. But you had to install Homebrew first. But
Yeah,
you know, Google for it and tells you how to do it. It's pretty simple. So
the Mac OS doesn't ship any GPL v3. They stripped everything out that's GPL v3. So for instance, their default bash is version 3, not 5. That's why they switched to Z shell. So if it's anything under 2.0 GPL, GNU tools will be in there. If it's 3.0, you won't see it.
Yeah. Suddenly I appeared. Yeah, I looked at installing awk on Windows, and it seemed to be a pain. I think the simplest way to use it on Windows is to use it in the Linux system inside of Windows, rather than, because I think mostly what I came away with is I was going to need to install Cygwin first, and then I could download the source code and compile it into Windows. It didn't seem like people were distributing an executable version for Windows.
Okay, yeah. So I'm looking at the your GitHub thing, and basically you have already created PDF for the regular, and then the extras you have a separate PDF.
Yeah, they should both be there. I think that there's a folder in there, a directory called awk, which is where a bunch of the larger pieces of script are. I might rearrange that a little bit because I think I've got some stuff in there that isn't going in there. Oh, somebody says there is a native version of gawk for Windows. And I just either didn't look at it or didn't pursue that. I guess I didn't see that. Okay, so read the chat. There you go.
Okay, so I'm looking. Oh, there we go. Download.
Yeah, somebody asked about how Bell Labs used awk and C and stuff. 70s was a bit before my time there, but everything was filed, text driven. And you can see that in this language, that is very oriented towards files of lines of text. And that, most files of data people collected were that way, documents were that way. You could, I suppose, use this to parse TRAW files or something. I don't think I'd recommend that, but so it was just another text-oriented way of doing things. In some sense, some of the stuff that's in there already exists. Some of this exists as said, as grep, as TR, all those kinds of routines. And you can use that, combine those in the shell to do many of the same kind of operations. But I guess these guys had some spare time, and one of them wrote compilers for a living. Well, two of them did. So they, came up with this, and everybody I knew was surprised to discover that there was anything like this sitting in there in the Unix system, even though it had been there for, what did I say? It started in '77, and the time I joined the company was like '85. It had been sitting there for a long time, and nobody I knew it even was there.
Anybody else have any more questions or comments, or we should give some praise to Kent?
Oh yes. So Kent, that was very.
That's the way you do it. That's the way you do applause.
I'll take it.
That was very good.
I had a quick question. Sorry, there's a lot of background. My kids are playing in the background. So I'm Professor Jeremy Hayek. I teach at IIT, and I teach some introduction to Linux classes. So I'm dealing with 21, 22, 23-year-old kids. Not the old argument of, is old better, is new better, but in your mind, and the presentation was really great because I knew a little bit about AWK and maybe the collective group's wisdom. How do you present AWK to somebody who's 22, 21? Not just saying like, well, here's this, part of history, but what's the explaining the full, how would you attack that if you were that teacher or writing textbooks or something?
Well, in a practical sense, I'm not sure I would, because they're probably, if they don't already, they're going to learn Python. And I can do pretty much all of this in Python. My reason for not liking Python has nothing to do with it as a useful language or its libraries or all that stuff. Those are all excellent. I just don't like using white space as a syntax element. And I only know of 3 things that do it. Python, a language called Promol, or maybe Comol, depending on the thing you're looking at. Extra points for anybody who's heard of that one. And Make, the build utility. So it's, of the millions of languages people have written, there's like, 2 that use that. So sorry, rant aside. Other than that, I mean, if they're using that already, I'm not sure it's a lot of benefit to learning another one. Python has the equivalent of associative arrays, so all the stuff you can do in there. There's some, eventually you have to stop teaching some stuff. How many assembler language classes do you have at IIT these days?
That's true. I guess a follow-up question too, with AWK coming like in 1977, do you see some of the design decisions kind of predate the major SQL databases?
Yes.
Right? You don't start to see Postgres, not Postgres, but Ingress and the other things that became the majors. So it was kind of designed in a world, we take SQL for granted, but a lot of it's design decisions. And one other follow-up question, the temperature examples you did, actually the exact same material was used in the O'Reilly book for the Definitive Guide to Hadoop. And in chapter 1, they did it to demonstrate that you can do this in AWK, but Hadoop, you can do it in a distributed fashion, and they kind of compared and contrast single core, single thread versus, divided over nodes. I don't know if you or any of the group thought about that, like the evolution of AWK into something like Spark and Hadoop, where you have distributed nodes versus, a large single thread.
Yeah, I'm not sure it's suited to that because, like you were saying, everything was, there were text-oriented files. There weren't real databases. You know, when I was in grad school, it wasn't a sure thing that relational databases was going to be the thing. So, you know, so I don't know that architecturally it, you know, I suppose you could do something like all the lines are processed in parallel or something that might speed it up, but I'm not sure the syntax is a natural for that either. So my view on this is like, I thought I was really surprised by this, you know, a decade in the last century. And so it was kind of cool that it was there. I was thinking of this as more like, here's a neat thing you didn't know about, rather than in my original version of this talk, there were actually going to be 3 parts to it. The first part was going to be a somewhat shorter version of this for awk. And then I was going to talk about Forth and Lisp, because Forth people might have heard of, but it's been kind of fallen out of favor. And Lisp, people would have heard about it in the same sense they've heard about COBOL or Fortran. But a lot of modern languages like Scala and, well, most of the functional programming languages are based off of Lisp, which dates back to the same time as COBOL and Fortran. So I was going to give a little introduction, you know, to that. But my Forth stuff never came together, and so then I just went with this.
Yeah, Lisp is still around. Clojure is a modern Lisp that Google's huge into. In fact, we're doing some teaching in some class for some event monitoring and monitoring metrics using Clojure. So Lisp is still there.
My last employer was a commodities trading company, and they were pursuing that a lot of Clojure, and you know, to get the parallelism to, you know, cut down that trading time from 10 milliseconds to, or no, they're going to go down to the microsecond range. So yeah, so it was just a little bit of a history lesson more than anything else. I was thinking a fun thing to do might be to have multiple people pick their favorite forgotten language and then give a little talk on it.
Yeah, yeah, that'd be great. Yeah, well, I appreciate it. Thank you very much.
You're welcome.
So Jeremy?
Yes?
Yeah, Scott. So I was just wondering because one of the things that they used to say, and I assume it's still true, is that your first language you learn, you got some basic ideas of languages, and as you add more languages, then you get a deeper understanding of certain things as you go into different languages that have different functionality. And
sure.
And the first time you run into some concept that you hadn't run into on your previous languages, you go, ooh, like this associative array thing, because if you're working with something that only pretty much worked with your base data types, then the first time you ran into something that had built in the idea of, oh, you have text that just defines your array into something, and then then you have really complicated ones. So I just, is that the way you were thinking about asking about whether or not awk would be something useful to provide certain ideas that you don't necessarily see in other languages? Or
yeah, that was kind of it. Also, just looking at from different perspectives, I was born in 1979, so I have a certain age, certain assumptions. Maybe some people were born in different times and they have a little more insight that I might not have than someone half my age. It's not just because they haven't been alive that long.
Yeah.
And learning that SQL databases didn't always exist. All right, that led to maybe
and that's another way of looking at things is what's your inputs and what outputs are you looking to do? So, and different systems, not necessarily languages, but different systems.
Yeah, I worked at Bell Labs.
Doing things.
I worked at Bell Labs and found in a wastebasket, which I still have, the Unix manual that says that you're probably going to want to have up to 4K of memory on your machine to run Unix. So yeah, you want to know why some of the stuff is got down to 2 characters? That's why.
Well, the systems I mostly worked on were like the 3B2, and this was a moderately large box, what we now consider a mini computer rather than a personal computer. but that little box could easily support 40, 50 people simultaneously because there was no graphics. It was so you could get away with a lot less processing power and memory than you can now. And I don't want to go back, to those days, but it's still part of that difference. Yeah, and sometimes knowing the way things might have been, like knowing about network databases and stuff, which some of those old database ideas, when they were fighting over what was going to be take over or win the competition at the time, were now what we would call NoSQL databases. It was a category. They're basically name equals value pairs, and that was being considered back then. And it's sort of like everything new is old. It's just everybody comes back around to it. With cloud computing, we're back to client server the way we were. Something you get as time goes on is, I guess, less impressed by the changes because it sounds like you did that before. It's just now, how many times have we seen AI be the big hot thing and then watch it fall down and not back up again? So, and somebody, where did it go? Grant P pointed out that there was a language called RPG, and it also used white space for part of its stuff. So I now have another thing to add to my little list.
Yeah, RPG. That's way back.
Yeah. It's and somebody actually heard of mumps. I'm astonished.
Oh yeah,
if you go to your documents,
back, you hear about all these things.
The computer terminal, and it has a screensaver that says Epic Systems. That was originally written in mumps. The people that started that company worked for the cancer center in Madison, where I worked after they left to go form their company. And they took the kind of database system that we have been developing and turned that into a full-blown medical database system. But at least in the early days, a lot of that code was written in mumps. And I'm told, unreliably, I think, that some of it still is. But I think in the intervening decades, they converted to something more sensible.
Hey, Kent.
Yeah.
So I worked at Bell Labs starting in '86 through the early '90s, and had quite a bit of experience with awk, just parsing data, just like you were showing here. Somebody mentioned, why would you use this today? Well, back then we didn't have Perl, and Perl was in its infancy. My impression was awk really wasn't the awk that you see today until they got to the second version, which we called inawk at the time. But the real reason that I still kind of want awk to progress is a gentleman named Chris Raming there at Bell Labs Research wrote a tool called awk.cc, which would take your awk script and convert it into a C file, which you would then compile. And I used that just obsessively. I knew Chris personally, and I've still kept in touch with him over the years. And unfortunately, he doesn't want to have a whole lot to do with it. My understanding as of a few years ago, Brian Kernighan convinced someone, I guess this was during the Lucent time frame, to release awk.cc as freeware or something of that nature. But it's a very old version, and my understanding is the people who've been playing with it have had almost zero luck getting it to work. So that would be absolutely awesome. My experience is that I got tremendous speed gains with that. This was compiled on the old Amdahl machines they had there. Interestingly enough, they did not see those speed gains when they compiled them on the old Spark stations. For some reason, the interpreted scripts versus the compiled scripts, there wasn't a lot of speed up. So I'm not sure why that happened. But I had hoped that awk.cc would kind of filter over into, let's say, Python and other languages where they would take a script, parse it to whatever Chris was doing, and turn these more modern languages like Python into an executable rather than an interpreted kind of thing. But I haven't seen anything like that.
That's I vaguely remember probably seeing AWK-CC. I don't think I ever used it, but that's really cool. I mean, that's you see a little bit of that same kind of philosophy now with people. There's a thing called not WebAssembly. Yeah, it's a WebAssembly. It's essentially it compiles your C code or something into JavaScript, so you can run it on your web page. And so you don't have to learn this new language. You just write it in your old language and somebody translates it. And with something like AWK-CC, you get this, I think, more expressive language that then you get the, because C is like one step above assembler and maybe two, but it's great. But you don't have things like the associative arrays without whole, big libraries and such. So I think you can express your ideas more quickly, in something like that in awk and then translate it. So that's a really cool thing.
Could you get maybe, I don't know if you're familiar with this, Larry Wall was an awk user and wrote Perl because he said he hit the limit of what awk could do. And maybe, and anyone else who has experience in this, when you saw the awk world and then Perl came around, could maybe give a little history or explain why Perl had enough to take off that awk, wasn't, or are they different? Is it apples and oranges?
I can't speak from any actual knowledge. Just my impression of it is Perl can do a lot with a small amount of text, small amount of code. I mean, literally in the sum of a small amount of characters, because it makes a set of assumptions. Kind of like awk makes these the same assumptions. That's why you could have this thing that, reverse the variables just with a couple, very tiny amount of code, because it already broke the line up. It already did all this stuff. And you just say, okay, we'll print $6 and poof, there you go. And Perl has some of the same things that it would, you didn't have to pass a parameter. It was always in $_. So it made your code smaller, and that was attractive to a bunch of people. And I get it because I've used it for a bunch of things, and it could do a lot of stuff. My problem with it is just that I would come back the next week and have no idea what it did anymore.
Don't you think, Kent, don't you think that awk is better at text processing than Perl? I mean,
I don't know. I'd say better.
Most of the examples you gave were all about text. Everything you handled.
That was the intention behind Perl. It was like a report generating thing. It was, you're using it.
Yeah, I suppose.
And it has a lot of built-in pattern matching and regex handling and all that kind of stuff. Yeah, and as being pointed out here in the chat, Perl has this CPAN thing, which is a well-constructed, easy to search, huge library of pre-existing code that you can just yank and stick in your code. They added a object-oriented aspect to it, which I don't really think improved anything, but it made it it gave other people a better or more interesting way to express their ideas. It has a lot going for it. It's just that I could never remember whether I needed a $sign this time or not, and that kind of thing. So it was just some fiddly bits of the syntax that they kind of put me off. But it was and is a very powerful language. I kind of had the feeling that for a lot of people, Python's taking its place.
Well, I think what Perl brought to the table was regular expressions. I don't think the original awk had the powerful regular expressions that Perl had, and that some of those regular expressions and syntax has been backported into Nawk and Gawk. So you kind of forget about that. And that's why Larry Wall hit the wall, is because, pun intended, because he didn't have regular expressions, and so he wrote it.
Yeah, you can do a tremendous amount with that if you're careful at it. But it's and aside, that joke aside, I am fond of regular expressions. But yeah, without them, awk would be, well, wouldn't be that much.
In the corporate environment, did we get a lot of awk being a write-only language? And no good documentation to go with it?
Yeah, I don't know. I think it depends. To some extent, it depends on, like, when I wrote Perl, it was more readable, which meant that Perl people didn't like it because I'm not being entirely facetious there. It's in the sense that it wasn't compact as it could be. It wasn't maybe even as fast because I wasn't, doing these things. But I just didn't do enough of it that I couldn't remember what I was doing. When I came back to it next week, it all fall. If I wrote it all the time, I would have gotten better at it. But I've done substantial things with it. I kind of forgot about awk pretty much after the events that I was describing. So later on, when I was doing some some indexing of a bunch of Mathematica code, so I had to hunt through all this text looking for things. It didn't even occur to me to use awk for that. I did it in Perl, and so it's one of the things that I think is people don't hear about. It's one of the reasons why I decided to do this. I wouldn't tell people, okay, this is the solution to some problems you have. An advantage of something like Python or Perl is I think really they're more general in intent, whereas awk was kind of intended to be read these files, break them up, analyze it, print it out, do stuff like that. And the fact that you could access the rest of the Unix commands meant you could expand beyond that to do more stuff with it. But since that kind of stuff is in Perl and Python from the ground up, they might actually be better choices. It was a fun thing for me to play with. It's like I learned icon, snowball, and spitball, and I've never really used any of those things, since then. But they were fun to use at the time.
Any more comments, questions from anybody? Speak up. We're doing well here.
So the plan is to grab the chat part here.
Yep, that's the plan.
Okay, good, because I'll look up through there, and if there's questions that I can throw some confusion at, I'll do that and put it up somewhere. It looks like there's a fair amount of activity, and there are people that have heard of mumps. I usually win that bet. Oh, now I remember what it was. WWII is write the value of the variable W if the value of I is true.
And that was from what?
That was mumps.
Oh.
And you could write those words out if you wanted, but nobody did. They only used the single character command names because it was smaller, and the operating system that went with mumps had like a 256, each block was 1K, and you had to fit everything in there. So all your variable names were 1 or 2 characters, and you used 1 or character things. So it just looked like noise.
Thank you so much.
You are welcome.
Thank you all.
Somebody asked for my email address. I'm going to put it in here again.